Gout Spelled Out, and we start right now. Gout is an inflammatory disease. That means swelling, heat, pain. If you ask a gout sufferer to rank their pain between 1 and 10, usually it's a 10. The inflammation in gout is usually specific. In other words, it occurs in the large joint of the toe on one foot or the other, or one knee or the other. The current gout hypothesis by the medical establishment is that you develop hyperuricemia. This means that you have elevated uric acid in your circulatory system. The uric acid diffuses into the joint where the gout flare is going to happen. This means that uric acid is going to move from the circulatory system into the synovial fluid that is bathing the cartilage. Then, once in the joint, the uric acid crystallizes and you have an interaction with the immune system and the gout flare happens. Bam! It is my contention that the standard hypothesis of gout is flawed for two reasons. First, let's look at the statistics. There's somewhere between 8 to 9 million people in the U.S. that suffer from gout. About 43 million people in the U.S. are hyperuricemic. That means they have high uric acid circulating in their blood supply. However, only a fraction of that 43 million people are ever going to have a gout flare. Of the people that do suffer from gout, the mean concentration of uric acid during the gout flare is 8.3 mg per deciliter, which is at the top of the reference range. And the reference range extends from 4 to 8. The important point here is that the mean concentration of uric acid is not elevated significantly above the reference range for most people that are suffering from gout. Moreover, a full 18% of the individuals suffering from gout have uric acid values between 6 and 8, and a full 14% have values of uric acid that are actually under 6. Additionally, monosodium urate crystals can be found in the joints of people who do not have gout. So the statistics tell us that while uric acid is indeed required for a gout flare, uric acid is not sufficient. There has to be other factors involved. Secondly, in this particular slide, I'm showing a paper that was published in 2010 by lead author Justin et al. That showed by in vitro and in vivo methods that in order to generate a gout flare, that monosodium urate was required, but also the addition of effector molecules were required for the complete flare. Monosodium urate alone did not generate a gout flare. So what is a better gout hypothesis, and why should we care? I am going to address the why should we care question first. And the reason why we should care is because we want strategies to attack the underlying cause of the gout condition in the first place, rather than treating symptoms. On this slide, we are looking at a very idealized version of my gout hypothesis. As promised, I want to break this down and keep it very simple, and then we will elevate in complexity. First, I want to draw your attention to the left side of the diagram, and we will start with the chondrocyte. The chondrocyte is a specialized biological cell that you find in our joints, and the function of the chondrocyte is to maintain the cartilage, provide nutrients, and keep the cartilage healthy. The chondrocyte, I believe, is one of the central figures in a gout flare, and in fact, I believe that low-grade inflammation and the role that intracellular uric acid plays here makes the chondrocyte sick, that then communicates with the innate immune system and a number of other factors to bring together the gout flare. Moving up, as I've already said, I have acknowledged the fact that uric acid is required for a gout flare. However, the exact role of uric acid is actually unknown. There are questions, for example, is the uric acid that drives the gout flare soluble? Or, to break this down, is the uric acid in liquid form? Or is it crystallized? Or is there a combination of crystallized uric acid and the liquid form of uric acid that's involved in the flare? These are questions that will only be answered in the future by the research groups that work in this area. Moving to the right, there's absolutely no question that the innate immune system is involved in the gout flare. Monocytes, lymphocytes, and also neutrophils are implicated in this process. Lastly, the two circles at the bottom. We know from at least one published source that I already presented to you, the Houston paper, that there are potential effectors involved in this, that you've got to have the monosodium urate in whatever form it's in, crystalline or in the liquid form, combined with something else. In the case of the Houston paper, it was free fatty acid combined with the monosodium urate that led to the gout flare. And lastly, there are a class of molecules that I group together as activators. These are the cytokines and the chemokines that are involved in the inflammatory cascade within the chondrocyte, and then when they are released, are involved in recruiting the innate immune system. Now let's get more specific. First, let's talk about the chondrocyte. The chondrocyte is found in the cartilage. It is bathed by synovial fluid, which is in contact with the circulatory system through a membrane. One of the things that we need to know about the synovial fluid is, can small molecules diffuse from the circulatory system into the synovial fluid, which is bathing the chondrocyte? And the answer is yes. If I draw your attention to the right side of the slide, we know that there are comparable concentrations of glucose, fructose, uric acid, free fatty acids, etc., found in the synovial fluid that have successfully diffused from the circulatory system into the synovial fluid, which bathes the chondrocytes. What is the functionality of the chondrocyte? And we see that the chondrocyte has all of the relevant transporters in its membrane. GLUT5 for fructose, and this is significant. It also has URAT1, which means that the chondrocyte can transport uric acid out of the cell, and it can also transport uric acid into the cell from the synovial fluid. Additionally, we know that the chondrocyte expresses the transcription factor JNK1, which is a very important protein because it's sitting at the top of the pinnacle of the inflammational cascade, in addition to the fact that there was a 2017 paper that showed the involvement of JNK1 as a protein in one of the key inflammasomes, the NLRP3 inflammasome, which is required for a gout flare. Finally, the chondrocyte also expresses IL-1 beta during the sudden acute rise in uric acid, and IL-1 beta is a cytokine which drives the inflammatory process. In addition, when it's released into the synovial fluid, recruits the innate immune system for the gout flare. Lastly, we know that the chondrocyte is a specialized glycolytic cell. That means it specializes in glycolysis. And under hyperglycemic conditions, under conditions that are high in glucose, which is typical of the standard American diet, the hyperglycemia, we know from substantial data, can activate the polyol pathway, leading to the production of endogenous fructose, which then will collapse into the production of a sudden acute rise in uric acid, which can lead to eventually to cellular death or apoptosis in terms of the chondrocyte. So now let's turn to what I consider a more effective and realistic model for the gout flare. Let's start with the left side of the cell. So we have the chondrocyte, which is undergoing low-grade inflammation because of an environment which is hyperglycemic most of the time because of the standard American diet. Remember, you can also have the contribution of both alcohol and fructose itself. This is something in my previous videos I have called the deadly triad. Exogenous fructose, the addition of alcohol, which is typical around the evening meal, for example, and then the hyperglycemic aspect of the standard American diet. This can lead to a chondrocyte which has low-grade inflammation. And then, when we have the combination of the deadly triad above a certain threshold, we can push the chondrocyte over the edge. It becomes sick. This sickness can lead to cellular death. In the process of the inflammatory response, we have the release of the effectors, of the potential effectors, monosodium urate, and also free fatty acids into the synovial space or the synovial fluid. To summarize, we have a sick and inflamed chondrocyte that releases effector and activator molecules into the synovial fluid. The innate immune system, neutrophils, lymphocytes, and monocytes are recruited to the site, and the combination of these events gives us the gout flare. Now, no discussion of the gout hypothesis would be complete unless we talk about the biochemical driver, fructose metabolism, that is responsible for the sudden acute rise in uric acid on an intracellular basis. And that's shown on the next slide. Generally speaking, fructose metabolism can be characterized the following three ways, or in a combination with any of these substrates. First and foremost, if we have exogenous fructose arriving at a cell and is transported into the cell, that fructose can be converted to fructose 1-phosphate by an enzyme called fructose kinase. And the result of that transformation, there is a massive depletion of ATP in the cell along with phosphate, with an inverse sudden acute rise in uric acid that is driving the systemic inflammation with the activation of IL-1 beta and the transcription factor JNK1. We have dysregulation of the nitric oxide pathway. We have reprogramming of the mitochondria and so on, that leads down the road to the chronic inflammatory condition that I described earlier in the chondrocyte. Now, we also have the interplay of alcohol and hyperglycemia through the polyol pathway. Alcohol has a myriad of effects, and I've described those in previous videos. I link one of them here. The hyperglycemia and the alcohol have its effect, like I said, polyol pathway, by activating an enzyme called aldose reductase. So in the presence of hyperglycemia, which is something that we know can happen in the synovial fluid with the chondrocyte, we can have the formation of endogenous fructose and then all of the cascading effects that are underneath that. The sudden rise in the in the uric acid, the systemic inflammation, dysregulation of nitric oxide, reprogramming of the mitochondria. Now, one downfall of this hypothesis is we actually don't know if the chondrocyte does fructose metabolism. However, what we do know, based on this 2015 paper by Laigian, is that the polyol pathway can indeed be activated in chondrocytes. However, even with these shortcomings, this hypothesis tends to explain the gout data that we have out there much better than the standard model that currently exists. And now we can talk about some strategies to potentially put gout in remission. Number one, it's a really good idea to stop eating sugar and alcohol. Those two things are very strong drivers of fructose metabolism. Altering your food pattern to eliminate hyperglycemia, making a better choice about what carbohydrates you eat and what condition they're in. This means giving up processed food, because processed food normally contains refined carbohydrates, high level of salts, including unhealthy fats. So step one in a gout remission eating plan would be to move to a real food, whole food model. You may also want to consider cutting down into the carbs and eating a lifestyle which is closer to being ketogenic and has the advantage of producing beta-hydroxybutyrate because of the fact that you are relying on burning fats for your primary macronutrients that you're utilizing. The advantage to producing beta-hydroxybutyrate is that this is a signaling molecule which has been shown in the literature to actually inhibit one of the central inflammasomes, NLRP3 inflammasome, that is required for the gout flare. Additionally, beta-hydroxybutyrate also dampens cravings, which makes it easier to give up sugar and also alcohol. I hope this presentation made it easier for you to understand the process of a gout flare and has provided you with the knowledge now so that you can come up with some strategies to get yourself into gout remission. If you enjoyed this presentation, please hit the subscribe button and the bell next to it so you know when the next time is that we are releasing a video. Thank you for watching.